This video demonstrates InfraGenie, Presidio's AI orchestration agent. Here we have an on-premise Linux virtual machine in vSphere. We will use InfraGenie for an AI-driven DevOps approach to migrate this VM to the cloud. InfraGenie begins the migration process by analyzing the existing Red Hat Enterprise Linux virtual machine directly from vSphere using the vSphere MCP Server. InfraGenie automatically discovers infrastructure dependencies, including compute sizing, attached storage, network configuration, and virtual hardware settings. It also identifies application-level dependencies such as running services, open ports, and process requirements, along with security dependencies like firewall rules and access considerations. Based on this analysis, InfraGenie highlights migration considerations for AWS, including compatibility risks, required configuration changes, and optimization opportunities. Finally, InfraGenie provides AWS-specific recommendations for instance types, storage options, and networking to ensure a smooth and efficient migration. With the dependency analysis complete, InfraGenie now generates a complete Terraform configuration to recreate the VM in AWS. InfraGenie creates all required Terraform files, including main.tf, variables.tf, and outputs.tf, following infrastructure as code best practices. It also generates a terraform.tf vars example file to simplify customization, along with a detailed readme.md explaining the project structure and deployment steps. To support system initialization, InfraGenie creates a user data shell script to configure the instance during launch. By leveraging Terraform and infrastructure as code, VM creation becomes declarative, repeatable, and version-controlled. This is a cloud best practice compared to traditional VMware provisioning, which is often manual and imperative. The entire Terraform project is generated automatically, accurately reflecting the original on-prem virtual machine while preparing it for scalable, automated cloud deployment. This approach standardizes deployments and enables reuse across environments. This reduces risk while accelerating cloud adoption. Next, we request InfraGenie to create a new GitLab repository and check in the complete Terraform configuration. Using the GitLab MCP Server, InfraGenie automatically provisions the repository, structures the project, and commits all Terraform files, documentation, and supporting scripts. Each file is version-controlled and ready for collaboration, review, and automation. This step transforms the migration from a manual task into a repeatable DevOps workflow, enabling teams to track changes, apply governance, and integrate CI pipelines. The infrastructure definition is now fully source-controlled and ready for deployment. Next, we will explore the newly created GitLab repository containing the full Terraform project. All configuration files, documentation, and scripts are checked in and ready for deployment. This enables version control, peer review, and automated pipelines as part of a modern DevOps workflow. InfraGenie now uses the Terraform and AWS MCP servers to deploy the virtual machine into AWS. The Terraform configuration is executed to provision compute, storage, and networking resources in the target AWS environment. For this demonstration, InfraGenie performs a direct deployment, though the same configuration could be executed through a GitLab pipeline. This approach ensures consistent, repeatable deployments across environments using infrastructure as code. This step shows how InfraGenie seamlessly bridges analysis, infrastructure as code, and cloud provisioning in a single automated workflow. The virtual machine is now successfully created in AWS. We can see the EC2 instance running and healthy in the AWS console. This demonstrates a complete DevOps-driven migration workflow, from on-prem analysis to cloud provisioning, powered entirely by InfraGenie. Finally, InfraGenie generates a detailed migration runbook for the cutover. The runbook outlines each step required to execute the migration, including pre-cutover validation, data synchronization, dependency verification, and rollback considerations. It documents roles, sequencing, timing, and risk mitigation strategies to ensure a controlled and predictable migration process. It also includes post-migration validation steps to confirm application health, performance, and security in the AWS environment. While this demo stops at provisioning the target AWS virtual machine, the runbook provides everything needed to complete the production cutover when ready. This completes an end-to-end DevOps migration approach, powered by Presidio's InfraGenie, from analysis to infrastructure creation to operational readiness.